Hello, in this video we are going to take a look at one-to-one functions and function inverses. So if a function is one-to-one, then it will have an inverse. And the best way to determine, especially if you're looking at a graph, the best way to determine if a function is one-to-one is to use what we call the horizontal line test. So to determine something is a function, we can use a vertical line test, and we say that it's not a function if a vertical line intersects it in more than one place. Well, the horizontal line test does almost the exact same thing for one-to-one functions. So the horizontal line test says that if any horizontal line intersects the graph of a function in more than one place, the function is not one-to-one. And so to determine whether these two graphs are those of one-to-one functions, we're going to look at a horizontal line. And we see that with our parabola here, our horizontal line intersects it in two places, so that means this is not one-to-one. For our rational function here on the second graph, none of our horizontal lines would intersect in more than one place. And so this function is one-to-one. All right, to determine whether two functions are inverses of each other, we have two different parts. We need to show that f of g of x is equal to x, and if g of f of x is equal to x. So first let's find f of g of x. For this example, our f of x is x cubed minus 7, and our g of x is the cube root of x plus 7. So we're going to take our g of x and plug it into our f function. So we're going to get the cube root of x plus 7 and plug that into our f function. So we'll get the cube root of x plus 7, quantity cubed, minus 7. Now when you do this, make sure that you follow order of operations. Our cube root here is over our entire x plus 7, so that cube root and the cubic function are inverse operations that will undo each other, and we'll be left with what's inside the radical, and then we still have our minus 7 on the end, and then combining like terms, x plus 7 minus 7 becomes just x, so that side works out. And then we need to find g of f of x. So now we're going to plug the other direction. So now we're going to plug that x cubed minus 7 into our g function, which is going to be the cube root of, instead of x, we're going to have x cubed minus 7. Then we still have that plus 7. Again, follow order of operations. We need to simplify underneath this radical first, because our x cubed and our cube root are not going to cancel out unless they are isolated. They are by themselves and there's no other operations happening in there. And so x cubed minus 7 plus 7 is going to simplify to just x cubed underneath that radical. And now we do have the cube root of x cubed is equal to x. And that side works out. Since they are both equal to x, they are inverses. All right, we're doing the same thing. Now our functions are 5x plus 8 and x plus 9 for f, and then our g is 9x minus 8 over x minus 5. So the first thing we want to do is find f of g of x. We're going to be plugging this whole fraction here in for the x's on our f function. So we're going to get f times that fraction, 9x minus 8, over 5 minus x, plus 8, all over that fraction, 9x minus 8, over 5 minus x, plus 9. And we need to simplify this. So when we simplify this, we need to multiply by our common denominator here. So between those four mini fractions, the denominators that we have are 5 minus x and 1. So we can multiply everything by 5 minus x and get rid of those fractions within our fractions. Make sure that you distribute that to all four of our terms. All right, when we distribute it to this first term, it's going to divide out and cancel out with that denominator, and we'll be left with 5 times our numerator, 9x minus 8. When we distribute it to this second term, nothing's going to cancel out, and so we'll just get 8 times that quantity, 5 minus x. On the denominator, our first term, it's going to cancel out, leaving us with that numerator. And then our second term, nothing's going to cancel out, and so we'll just get 9 times 5 minus x. We can distribute and combine like terms. And so 5 times 9x is 45x. 5 times negative 8 is negative 40. 8 times 5 is positive 40. And 8 times negative x is minus 8x. In the denominator, we've got 9x minus 8, and then distributing that 9, we get 45x minus, or 45 minus 9x. And then when we combine like terms in the numerator, we've got a plus 40 and a minus 40. So 45x minus 8 is going to be 37x. And then in the denominator, we've got 9x and negative 9x that are going to add to 0. And so we get negative 8 plus 45 is 37. So we do get those 37s to cancel out, and we get it equal to x. And then let's check our other direction. G of f of x now we're going to plug in the other direction. So we're going to be taking our f of x and plugging it in for the two x's in our g function. So we're going to get 9 times that fraction, 5x plus 8 over x plus 9, minus 8 in the numerator. In the denominator, we're going to get 5 minus that fraction, 5x plus 8 over x plus 9. And then just like we did on the last one, let's multiply by that denominator of x plus 9. Distribute that to all four of our terms. All right, for our first term, that x plus 9 is going to cancel in the denominator, and we'll be left with 9 times that numerator. Nothing's going to cancel on our second term, so we get 8 times x plus 9. In the denominator, we get 5 times x plus 9, minus everything cancels in our denominator here, and we're left with 5x plus 8. The most common mistake here is going to be to leave off those parentheses. Make sure that you don't fall into that trap, and distribute that negative. So let's distribute our 9 and our negative 8, and then the negative that we have here in the denominator. So we get 45x plus 72 minus 45x minus 8x minus 72. In the denominator, you get 5x plus 45 and negative 5x minus 8. Our 72's in the numerator add to 0, and again we're left with 37x. In the denominator, our 5x's add to 0, and we're left with 37, which does simplify to x. And since we did get both of those equal to x, they are inverses. If you get either one of them to be equal to anything other than x by itself, so if it simplifies to x plus 5 or 2x or anything that is not just x by itself, then they will not be inverses. All right, now let's look at the relationship on a graph. So if we wanted to graph the inverse of this function, inverses are switching our x and y values. And so if we wanted to graph this inverse, we're just going to switch all of our x and y values. We're going to reflect our graph across the line y equal x. So the point 4, 4, well, if we switch our x and our y, it's still going to be at 4, 4. The point 3, 0, if we switch our x and y, is going to be at 0, 3. So that's going to be a y-intercept instead of an x-intercept. And the same thing's going to happen with our y-intercept. Is going to become an x-intercept at, instead of 0, negative 1, it becomes negative 1, 0. And then our last point is at negative 5, negative 5. So if we reflect that, it's going to stay at negative 5, negative 5. So all we're doing here is switching our x and y values. And so our graph ends up being a mirror image across that line, y equal x. So this would be the function of f inverse of x. All right, I'll see you guys next time.